Hello Internet, it's Emil again with another mental sound box, that's what I'll call it. So this time I'm just going to do a little bit of a run through of this boombox that I built recently. So the last thing that I put up on my YouTube channel was my sort of music production setup, little battery powered thing. This one is less about making music and more about just playing it really loud. So just to give a bit of an overview, I had this boombox knocking around for years and years. I actually found it on the street in like 2006 or 2007. Pretty much, if you just ignore everything above this kind of line, that's originally what it was. And I think it was 8 watts per channel. They had little full range drivers in there. And it was just one of those classic old school little boom boxes. It sounded awful, but you know, it worked for a little while. Then eventually it started biting the dust. I think some of the transistors started to go, which actually meant it made a really good stereo distortion unit for a while. I was running synths into the line in and recording the output and sort of playing with the volume and yeah, just distorting it a lot. It sounded really good. So I actually did create a sample pack with some sounds from that, which I'll link somewhere. So after that, it did actually properly die a real death, and I couldn't really bear to part with it. So I decided to hang on to it for a while to revamp it at some point, and that point is now. It's finally happened. I've had it knocking around in pieces for a couple of years. And basically what I've done is I gutted the whole entire thing, completely emptied it out. I replaced the drivers with, so the old full range drivers are now just these mid-bass drivers. They are Dayton Audio TCP115s, I think is what they're called. I've also added some crossovers and tweeters, so it's a kind of two-way design now. I mounted these junction boxes on top, basically just to increase the enclosure volume. So actually what I did was cut a big hole in the top of the speaker cabinet and a big hole in the bottom of the junction box, and I've sort of bolted them together and silicon sealed them as well, so that is now additional enclosure volume up there. And then you can see, if I turn it to the side, tilt the camera up a bit, so you can see I've got these big kind of ports or horns on the top. I think technically they're probably transmission lines, although I think transmission lines, do they have to flare a bit? I can't remember. Either way, it's the same area all the way through, but there's basically a port in the back of this junction box at the top, and then there's a channel inside this big 3D printed, we'll call it a port, that basically just goes all the way down, back up, down, up, and then blasts all the noise out the front at your face. And I've never designed speakers before. I have a pretty good idea of how it all works, but I've never really had a reason to do it. So it was quite interesting. I did a lot of reading, loaded up WinISD, which is like a piece of software that basically does all the maths for you. So based on the specific drivers that I'm using, the enclosure volume that I had to figure out, this port is a certain length and a certain area of the cross section, and what that means is that this port is tuned to 40 Hertz. Now, while the main sort of woofers don't actually really go down that far, I think they start rolling off about 50, which is pretty good. And I managed to get that a bit lower because of the design that I've come up with here. But the reason I had these tuned lower than the actual sort of, frequency response of the drivers is because if I had them tuned higher than that, then it would have created a kind of resonant peak in the frequency response. Doing it this way actually it helped me to extend the low end a little bit and avoid any sort of, high Q in the low end. The one thing that I do still need to do to sort of round off the low end and get it working properly is basically add a subsonic filter somewhere. The reason I need a subsonic filter is because these drivers, obviously they could be trying to reproduce lower frequencies than those that are actually going to be audible from this system. So for example, if they're working really hard trying to produce 30 Hertz sine wave or something, what might happen is, first of all, they'll eat up a lot of my headroom. There's a certain amount of, I think the whole system is 90 watts, and it'll be wasting a load of energy trying to reproduce those frequencies. But also, if I have it cranked up pretty loud, then what's going to happen is the X-max of the driver, which is the maximum excursion distance, will be exceeded by the drivers trying to reproduce that frequency, and that will cause all kinds of distortion in the low end and nasty stuff like that. So my solution to that was to mount a Raspberry Pi inside the kind of main unit, and I had that running Patchbox OS by Blockus Labs, I think that's how you say it, and that was great because it meant I could run something called Modep, which is basically a kind of effects chain thing. I mean, it's way overpowered for this application. It's really, it's for guitarists or people who are running like, huge effects chains on instruments and stuff, and it's got a whole web interface. It's supposed to be very tweakable and that kind of thing. But the reason it worked well for me is because it basically means I can stick my 35 Hertz Butterworth filter at the bottom. I could even do some EQ and some limiting at the end. The only problem I ran into was that, basically, the Raspberry Pi had to run off the same power supply as the amp that's in here via USB, and that created a whole load of horrible electrical interference in the signal path, which I could not get rid of at all. So the only other option was to basically run it off a separate power supply. However, one thing that I did try to do, if I flip it around back, you'll see underneath this old battery compartment, and actually this is quite nice, this TJ Electronics Limited, it's down the road from where I grew up, where I found the Boombox actually. They must have sold it or serviced it or something in the 80s, and their sticker's still on there, and they are actually still in business as well. It's quite nice. Anyway, if I open this up, this is the battery pack. It's DC battery pack, so we'll do 90 watts out of this DC out port here. It's also got these two USB ports on it, there's one there, and I thought that maybe, because I was powering the Raspberry Pi from USB Type-C, which has power delivery, which basically means it's doing a data exchange, I thought maybe that data exchange could be causing lots of interference on the line. So I thought maybe I'll instead just connect it to a regular USB port. I stripped an old USB cable just down to the positive and negative power lines, so there's no data in there at all, and tried to connect that directly to the Raspberry Pi GPIO pins to avoid any USB-C of any kind. Unfortunately, what I didn't realise was if I turn this on, I have to flick through these voltages to get up to what I want for this, which is 20 volts. It turns out that these are not standards compliant USB ports. What that means is that I ended up sending 20 volts directly to the GPIOs of the Raspberry Pi, and I killed it. And I killed my somewhat expensive Hi-Fi Berry ADC plus DAC Pro, I think it's called. It's like the audio interface hat that was on the Pi. So that's a no-go. At the moment, I'm running it with no EQ and no high-pass filter or anything. So I need to resolve that at some point soon. Luckily, the amp I'm using has these little, I guess they're just shelves, just a low and high shelf EQ on it, which means that I can at least get it sounding somewhat balanced, which is important because these low-end drivers are not that efficient. I think it's something like 86 dB SPL. The tweeters are much, much more efficient. The crossovers run at 4 kilohertz, so everything above 4K is basically just way too loud. I don't know what frequency this high shelf is crossed over at, but it works well enough that I can get a pretty balanced sound coming out of it, so I'm kind of lucky for that. But the next step at some point will be to either put another Raspberry Pi back in it with Patchbox, or maybe a lower power solution like a Teensy with an audio shield or something like that. If I do that, then it'll be much more complicated getting some DSP running on it, because I'll probably have to write it myself, but we'll see what happens. So regarding the actual build, I can crack open one of these speakers so you can see what's happening inside. Oh yeah, I've got these cables. The reason I've got these cables sort of hanging out everywhere is because these speakers are actually detachable. So you can see there's a little latch there at the bottom. They slide up, and then you can kind of reposition them, which is really nice. It sounds much better when the speakers are a bit further away, partly because it means I've got a nice sort of wider stereo field, but also this thing's made of plastic and it's really creaky, and if you're running really loud bass through it, then the whole thing just starts rattling. Detaching the speakers helps with that quite a lot. So anyway, I'll get rid of this bit, and I'll kind of show you a bit about what's going on in here. Right, so I can't really take this all the way off because there's wires connected, and that's my crossover mounted in the top. I think this crossover is actually quite a bit overpowered for this build. It's rated for something like, I think it was 250 watts or something. The whole system's only 45 watts per channel, so it's kind of unnecessary, but it was cheap on Amazon, and it seems like it's, you know, reasonably well put together. If you look in, oh, I'm dropping bolts everywhere. So I think you can see, maybe I'll bring this a bit closer. Oh, the bolts, I should have taken them out properly, shouldn't I? Right, so I'm going to try and tilt this down a bit. So in here, you can see there's the little cutout for the port, and it's filled with that red stuff's all just silicone sealant in the back there. And there's this junction box. It's designed to be like an outdoor weatherproof junction box, so it's got this weather strip going all around the edge, which I didn't really have a lot of confidence in, but it turns out it works really well. Like, there's not really any air leaking through there or anything when it's playing, so that's good. And then if you look inside here, obviously I've got some insulation material in there. I don't know if you're going to be able to see. Maybe if I tilt it up a bit. Need some light. So there's that little blue ring inside there. I don't know if you can see. But that's a mounting bracket that I had to make to get the drivers to fit in there properly, because the mounting holes are in slightly different places to the original drivers on here. So yeah, I mean, the whole thing, as you can see, is all sealed up with loads of silicone, got some insulation in there and stuff like that. And pretty simple, really, just how it fits together. So that just goes back on there, and I will put that to one side for a bit. Kind of sandwiched in, so when I take those screws out, the front falls off, and then with any luck, the back falls off as well. Take this power cable out. There we go. So it just sort of disassembles itself. So I'm going to gently take out this battery pack. That actually just slides in and out, which is quite useful because it means I can just take the battery compartment off the back of here, pull the battery pack out, and then I can use it if I actually need a battery pack. There's a little 3D printed bracket there just holding that on. So I will carefully just move this to one side and not lose the screws. So in here, you can kind of see what's going on. There's the amp board. I can't remember what it's called, it might say on the back. It's a ZK52T, which is just a cheap, I think it was like £20 off Amazon or something. It's rated for 100 watts, I think. And yeah, it's just really quite straightforward. So the DC power comes in here. If you look up here at the top, this curly purple wire here, the reason I put that in actually is because there's another, this amp has a Bluetooth receiver built in, but there is another Bluetooth receiver module up here, and basically that goes to this 3.5 millimeter, sorry, jack there, and then I've just wired it outside straight back into this, which is the auxiliary input to the amp. The reason I did that is just so it'd be really easy to just pull one of these cables out and plug someone's phone in or something like that if they didn't have, or any device that doesn't have Bluetooth basically. But the reason I had this all set up is because that auxiliary cable was not supposed to go straight into the amp. It was supposed to go into this, which is a Raspberry Pi case, and then that would do the DSP processing, and then that would run into the amp afterwards. So I still have yet to fill this and figure out what I'm going to do with it, but that's the basic concept. And then, you know, standard speaker wire for the left and right channels goes to these 1/4" jack outputs, and then they just get wired into the speakers. So yeah, it's really quite straightforward inside. I mean, this whole sort of chassis is basically empty, and that's pretty much it. So I'm going to put it back together, and I'll see you in a sec. Now, the sound is probably going to be awful because I'm just using a crappy lapel mic. I don't know how much of it's going to come through, but I might as well just chuck something on there. Maybe I will play something of mine so that I'm not breaching anyone's copyright. Just cut to the drop. Now, I have no idea how well that's coming through, but that's just a touch over half volume. It does go very, very loud. Already it's shaking the floor. So, yeah, I mean, it's pretty much the most ridiculous Bluetooth speaker I could ever hope for. The battery life is really good as well. Like, I've taken it out and played it all day at about half volume, which, as I said, is pretty bloody loud. And, you know, end of the day, I've still got, what, 30-40% battery left. So, yeah, it's pretty much exactly what I wanted. And, yeah, I might post more updates when I start doing the DSP stuff with it later down the line, because I really do want to do that at some point. At the moment, when I crank it up to full volume, I do get quite a bit of distortion in the low end. So, yeah, that's about it. See you later. Nice one.